this video, I'm going to still be looking at solving quadratics, but I'm going to use the method of completing the square. Now, this video is intended for an Algebra 1 audience. This is not their first time seeing the completing the square. This is part 2. So again, the skill level here is more for an Algebra 1 group. If this problem comes across too hard, in the video description, I'm going to link my part 1 to this. If this question is too easy and you want to see more examples of completing the square, I linked my Algebra 2 stuff as well in the comments. So if you need more completing the square help, check the comments for those videos. So let's get to it. Completing the square. When I see completing the square, my mind immediately goes to doing b divided by 2 squared. That's where my mind goes. Now, when we're thinking about b, like where does this b come from? A, in a quadratic that's set equal to 0. A is just the coefficients or the numbers in front of x squared. B is always in front of the x. And C is our constant. So if I want to complete the square, I'll move a little bit quicker because, again, this is part 2 on how to do this. First thing we're going to do is clear out that 18. So I'm going to move that 18 across. Move that 18 across because we're going to reconstruct this left side. So we have x squared plus 10x, going to leave a little bit of room. 0 minus 18 is negative 18. So I move that C piece across there. Once we've done that, we are set up to complete the square. Now the idea here is we had something that couldn't be factored originally. This could not be factored. By completing the square, we're going to reshape things on this left side so it can be factored. So I need to do b divided by 2 and square it. So I'm going to take that b, which in our case is 10. Take 10 divided by 2, and then we're going to square it. 10 divided by 2 being 5. 5 squared is 25. Okay, so what I'm going to do is take this piece where I did my b divided by 2 and squared it. Let's take this 25 and let's add it to the left side of this equation. But to achieve balance here, if I'm going to add 25 to the left side, I need to add 25 to the right side as well. We got to get that balance back and forth. So left side of this equation is going to be an x squared plus 10x plus 25. Right side, negative 18 plus 25 is going to be 7. Okay. So the point, the objective with completing the square is we wanted to take something that couldn't be factored, and by completing the square is something that can be factored. So we're now going to factor. We're looking for two numbers that multiply to 25. Those same two numbers need to be able to add to 10. So trying to find two numbers that multiply to 25 and add to 10. My number sense is telling me if I use positive 5 and positive 5. 5 times 5 is 25. 5 plus 5 is 10. So x plus 5 and x plus 5 are my factors, and I didn't quite touch that right side yet. Okay, so when I look at this left side, I see a parentheses of x plus 5 and a parentheses of x plus 5. These are the exact same. So what I can do is I can condense these down to a single parentheses, but just make it squared. Instead of writing it out twice, let's write it out once. Squared equals 7. From here, I now have something that can be solved. And that ultimately was our goal as we're trying to solve this quadratic. We're trying to solve for x. So that's now what we're going to do here. I'm trying to get to x, but there's 5 and that square in the way. So I'm going to start by getting rid of the square by doing a square root on the left and a square root on the right. So on the left side, we get a little bit closer to our x. We got an x plus 5. On the right, we got to try and figure out the square root of 7. Now here's the deal. I know how to do the square root of, say, 4. I know how to do the square root of, say, 9, but I don't know the square root of 7, and I can't break down the square root of 7. So what I'm going to do is I'm going to leave it as a positive or negative square root of 7. It cannot be broken down. If you're not sure on that, you could even check on the calculator and do a square root of 7, and you're just going to get kicked back a decimal, which we don't want to work with that either. So we're going to leave it as plus or minus square root of 7. From here, we have to account for both instances here. I have to be concerned whenever this is equal to the positive square root of 7 and when this is equal to a negative square root of 7. So what I'm going to do is I'm going to split up this problem. One of them is going to be x plus 5 equals positive square root of 7. And the other one is going to be x plus 5 equals negative square root of 7. From there, we're just solving. We're just solving. Got to get x by itself, so I'm going to subtract 5, subtract 5. We get our x by itself, which is our goal, but we got a negative 5 and a positive square root of 7. A negative 5 and a positive square root of 7, they are not like terms. They are not like terms, so I'm going to leave the negative 5 alone and the positive square root of 7. Negative 5 and positive square root of 7. We're going to leave them separated. That, as ugly as it is, that is one of my solutions. To the right side, subtract 5, subtract 5. Again, we have an instance of these are not like terms, so I'm going to leave the negative 5 alone and the negative square root of 7 separate. So we have a negative 5 minus the square root of 7. Can't do anything else with that either. That is my other solution. Okay, so this is completing the square. It's all about moving that C piece across, moving that third piece across, and then b divided by 2 squared, b divided by 2 squared, and making sure we do it on both sides, and then factoring and solving.